Here we go. We have a question. Count of substrings containing every vowel and k constraints part 2. So you are given a string word and a non-negative integer k. We need to return the total number of substrings of word that contains every vowel, which means a, e, i, o, u, at least once and exactly k constants. So we have given this string and we need to find the number of substrings that contains every vowel and exactly k. In this case k is 1 and one constant, so a is found, e, I, o, so u is not there, so u is not there even in full string, so the answer is 0. We don't have any substrings. In this case a, e, I, o, u and k is 0, so 0 constants, so there's only one substring. And in this case this is a very long string and we need to find a, e, I, o, u and one constant, so there's three values in it. There's three substrings, so the answer is 3 in this case. Let's build the approach. So I am making this video late at night. Anyways, let's take a string, so which include a, e, I, o, u, a, e, I, o also contains, then u. Okay, so we have a string here and we need to find every vowel. So first condition is every vowel, the next condition is constants is exactly k. So let's focus on this statement only first. So constant k only, we need to find only means exactly k constants. So one thing to note here is, so if I find at least k constants, then if I subtract minus at least k plus 1 constants, so we got exactly k, constant strings. And why this is useful? So if a question is given in this way, we need to find exactly k. So for that we can utilize this simple technique. First we find at least k, so at least k is easy to find as compared to exactly k, so this is easy to find as compared to this. So if I find this, then this is also simple, and this thing minus the second thing is equal to exactly k. How? So let's suppose k is 5 and our n is 8. Okay, so at least 5 means k is 5, k is 6, k is 7, k is 8, right? So at least k plus 1, it means k is 6, k is 7, k is 8. So this will cancel out and we got only exactly that. So we can utilize this technique. So let's first find instead of this, let's find, so I am changing the problem statement. So we need to find every vowel and at least k constant, then I will subtract every vowel minus every vowel and at least k plus 1 constant. So I will do this thing. So in this test case the answer can be very big. Anyways, let's build the let's run this. So how we gonna solve this? First we have a, e, I, o, so we need to find a window, and after that every string will be valid. So let me prove it. So let's start the window. We find A, so let me add A. Then we find B, so A, we also need to, this is for vowel, and we also need to consider how many times A occurred. So this is my map. Then we find B, and let's suppose my K is, what is my K? My K is 3 only. Okay, so then we find B. So my constants, my constant is 1. Then we find E is 1. Then we find I is also vowel. Then we find E, so E is also vowel. Then we again go, then we again extend it, so we find a constant. Then we find O, 1. Then we find B is constant, so we find a valid, a valid thing. I, okay, no, our E occurrence is 2. Our E occurrence is 2. Then we find this thing, what is this? This is B. So we have found B, Z and B is constant. Okay, so we have found 3 constant which is equal to K, but our first condition, which is this every vowel, is not satisfied till now, till yet. Then we again move forward. We found a U which is 1. Okay, so this is a valid window. This is a valid window. Our both conditions satisfied. We have found exact, we have found vowel at least once, and we have at least K constant. We have at least 3 constants, right? So what, how many more substrings we find if we start from this? So this is a valid substring, this is also 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 a valid substring, right? So let me give it indexes. And our length is 13. So if our condition is fulfilled, so can we write it like this? Answer plus equal to, so this is 1, then 2, 3, 4, 5. So 5 strings starting from this value is valid, right? Yes. So 13, which is my n, minus my current length. What is my current length? My current length is 8, so which gives me 5, right? So let's say, so till now this is a valid substring, so I can write it like this, n minus r, right? Yes. So our answer is 5 till now. Then let's let's collapse the window. So we are collapsing, we are incrementing our L. So our this thing, our A decrements, and our A is now 0. It means we don't have any A, and this condition is not satisfied. Okay, so this condition is not satisfied, this substring is not valid, so we need to extend the substring. So then we find A, so this A, so A string is now 1, A string is now 1, right? So this is a valid substring, this is also valid, this is also valid, this is also valid, right? So I can also write 13 minus 9, which is equal to 4. So we have found 4 more substrings, right? So we have found 4 more substrings, so the answer is 9, right? Then we collapse, we try to collapse it. So I am collapsing from the starting index. Then we erased our B. We erased our B. B is our constant. B is our constant. Now constant decrements. We have, in this window we have only 2 constants. One is this, which is Z. Then another one is B. Right. So our constant is 2. We have at least this thing is not valid. Right. We need 3 things. But this is not valid. It means we need more elements. So let's expand our window. So then we find a B. We find a B. It means we find one. We find a constant. So our constant is now 3. Constant counter now becomes 3, right? Yes. So our both condition fulfilled, every vowel and at least k, right? So we have found 10. 10 minus, oh sorry, 13. 13 minus 10, it means we have found 3 more substring. One is this, second one is this, third one is this, right? So we have found 3 more substrings. So the answer is 12. Then we try to collapse. We uh, E, and E is outside the window, so it decrements, but still this is a valid window. And what's the substring length? What's the how many substrings starting from index 3? 3 substrings, right? Yes, 3 substrings. So our answer becomes 15, right? Yes. So then we again try to collapse it. So then our E is out of the window. Then this is not valid, right? This is not valid. Then we try to add more such elements, B, which increments our counter. Then we increment B, B increments our counter. Then that's it. So we have found uh, 15 such substrings, 15 15 such substrings in which these two condition is valid, right? Then 15 minus, then we try to calculate this. So whatever the value will be, so let's say 10. So the left out value is fulfilling these two condition. It means we have every vowel and exactly k constant, right? So that's how this approach will work. Let's quickly code this. So let me create a function, because we need to call it two times, one for k, one for k plus 1. So let's say at least k times, then at least k plus 1 times, at least and we have k. So this is for map. We need a map. Then what we need window, L and R window. We need length also, right? We need uh, constant counter. So this is uh, const count, right? And we need answer also, while R is less than n, right? So we find a character which is my rs character. And if my rs character is vowel, so we need to differentiate it with vowel and constant. So if this rs character is vowel, just put it into the map. If that character is already there, just increment the counter. So do that operation. We can use merge function in map. I already discussed about the merge function many times. So I am merging current character, and if vowel is function is not implemented, I will implement it. Otherwise this is a constant, so just increment constant counter. It's time to create this is vowel function. So this is C. If C is A, either A, E, I, then O, then U. Okay, so we are placing in map. Then if these two condition is fulfilled, either our so we need to fulfill these two conditions. So map size is 5 means we have found every vowel, and the constant counter is at least means greater than or equal to k, right? Then this substring is valid, and we need to find how long this substring is. So starting from the lth character to the rth character, this is a valid substring. Then from rth to n, from rth to n, all the substrings are valid, so we can write it like this, right? Then we are collapsing our window, we are incrementing our l. So let's get the character on lth, which is on our what we say left hand side. So we are collapsing our window from left hand side. So if that character is vowel, so we need to also do the same thing. If that character is a vowel, what means our lth character is a vowel, then we are decrementing. And if this is a constant, just decrement that counter. And if my vowels counter is 0, so just remove it from the map, right? And I forgot to update my L and R, then just return the answer, as simple as that. So let me run this. Yes, let's submit this. Yes, working fine. Let's discuss about the time and space complexity. So first we are calling at least k. So we have this while loop here. Then is a vowel is order of 1 only. This merge function is order of 1 only. Then this while condition. So this either this thing will run, either my L will update or my R will update. So the time complexity is 2n, not n square. Yes, we have while condition inside while condition, but this is a simple sliding window technique, and in the sliding window we have order of n time complexity. So either my L will increment or my R will increment. So my time complexity is order of 2n, or 2 is constant, so we can say this is order of n minus order of n. So in the worst case it will run for order of n only. So this is my space, this is my time complexity. And what about space? So I have a map. So how many items map will store? In the worst case, map will store 5 items only, and apart from it I am not utilizing any more space. So my space is constant, my time is order of n. That's all about the time and space complexity. Code is provided in the description box. Thank you all for watching this video.